Hello everyone. I would like to introduce you all to Intro to IoT and Robotics. And today we have a first session, Introduction to the Arduino World. I'm Janvi, the core member of DSC ASCB. Without a further ado, let's jump right into the IoT. So IoT basically refers to a system of connected objects. So we're able to collect and transfer data over a wireless network without human intervention. So this can be has multiple possibilities. This could be of like personal possibilities and business possibilities. And here I refer to the billions of physical devices connected around the world, and they are sharing and collecting data at the similar time. So this is all possible due to the arrival of super cheap computer chips. So and wireless network. So because of these two, it was possible to turn anything from a small pill to as big as an aeroplane with as a part of IoT. So basically, IoT devices contain sensors and mini computer processors. They all act on the data collected by the sensors via some machine. So these machines are compute like they use machine learning, and they like learn to behave the similar way the humans do. So by this they collect the data from the surroundings, and this is what makes the IoT devices smart. The term Internet of Things basically refers to anything which is connected to internet. It could be a man who has a chip on his heart, or it could be your smartwatch. So basically they are all connected over internet. And here the systems are also referred to as to be smart and connected. So here all not all IoT devices need an internet connection to function properly, but there are few which require the connection to other gadgets on the network to automate a certain task. For example, your phone, you can automate stuff in your house using your phone. So then for that you need a connection between your phone and the items of your house. This will allow it to interact via direct commands, or you can customize its configuration. So basically, the contain sensors. So with some help of some simple code, the Arduino can control and interact with a wide variety of sensors. And these sensors can measure things like light, temperature, pressure, proximity, acceleration, etc. So now moving, and these sensors are the ones that usually give inputs to the Arduino. So they collect information from the outside world, and then they put it into a system, and the all the data is transferred into the to the Arduino, and we get the output from that. So applications of IoT. First, the most and the widely used application of IoT is smart homes. So it is filled with products with possibilities that like makes our lives more easy, convenient, and comfortable. It also is noted that it has total use of above 2.5 billion, and it also includes like prominent startups such as Philips and Haier. They generally use it. And then second area comes wearables. So most of them are connected with your smartphones, like devices worn on your wrist. For example, like smartwatches, and then devices you can like Google Smart Glass and all that. And also you have sensors which are like skin color, like suppose a tattoo patch. So all these are applications of IoT. Smart city. Smart city includes traffic management to water distribution, waste management, and urban security and environmental monitoring. So many smart city solutions have like they are comprising, and they have like promised to remove the real pains of people living in the city these days. So IoT solutions in these smart areas solve problems such as traffic congestion problems, reduce noise, and also help in pollution and help the make the cities safer. Now medical and healthcare system, it's basically like it helps in determining your pulse rate and all that. So it's basically, for example, I gave an example of wristwatch. So there, that time the wristwatch scans your pulse and sends it to your phone. So in that way, it is used in a medical and healthcare system. Next, it is used in industrial IoT. So this in industrial IoT, it basically aims at improving productivity and efficiency in businesses. So many market researchers like Cisco, they consider industrial IoT to be the highest overall potential, and it is a very trending topic. For example, we know the smart grid. So this smart grid uses information about the behavior of electricity suppliers and consumers in a certain industry. For example, take automated fashion. So now this smart city helps in various technologies such as they deliver power more efficiently, they improve the operations of the machine, they reduce the emissions and management cost, and restore power failures. So all this is possible with IoT, and they do it by themselves. Next, I would like to explain what an embedded system is. So an embedded system is something which controls a process, to be very simple. So embedded means nothing but it is attached to another thing. So an embedded system can be thought of something like a computer hardware having a having a software embedded in it. So an embedded system can be an independent system, or it can be a part of another large system doing its work. In the case of Arduino, it is generally the microcontroller or microprocessor based system, and it is basically contains various stuff like memory, and we can also put in our inputs there. Now I'll give you another example of embedded system is a fire alarm. So a fire alarm is an embedded system whose work is to sense smoke. Now, this embedded system can be said to have three components. It is the hardware component, and it has some software application embedded in it so that we can get the input like how the amount of smoke and all that. And it has a real-time operating system. So now this real-time operating system supervises the application software and provides mechanism to let the processor run the process as per the schedule. So it basically lets us know that when there is smoke. So now it defines the way this system works. And also a small scale embedded system may not have an ROS. So basically, if I tell this is the taking this example, this is the embedded system. Okay, let's consider this to be a computer. It has a certain hardware like hard disk and all that, and a certain software. So suppose we're giving an input variable. Suppose we're using this Google slide for example. So this is an input variable. So we are trying to show it over to someone else. So in that way, we're trying to present it. So here, the all these actions take place in this embedded system, and the output variable is that now you're able to view my screen. So this is it all about embedded system. So now examples of embedded system is that characteristics of it, the embedded system is generally autonomous or real time, as I said. So in autonomous, it must fulfill its mission for a longer period of time. And here it might or might not have a human intervention, or it have a very less power consumption. Whereas in real time, the response times of these systems are like very accurate results within set deadlines. And they also have a deficient maintenance with low cost, like it is for a specific task. Now I'd like to move on to Arduino. So Arduino is basically a microcontroller board based on the 8-bit Atmega 328P microcontroller. So this Arduino has 14 digital input and output pins, which I'd be telling as IO pins, and it has six six pulse width modulation outputs, which was generally represented using these complement symbols. So, and it has six analog input pins. So, these are the six analog input pins. It has a USB connection. So, this is the USB connection. Generally, whatever code you write in your computer, so you would put it into the your Arduino Uno using this power cable, sorry, USB connection, and it has a power barrel jack here, so basically where the power gets in, and an ICSP header and a reset button. So this reset button is where you can restart your uh, Arduino. So basically now it has something called computational intelligence. So within the microprocessor you have a lot of things known as RAM and all that. So these parts are again integrated. So next I'll move to the various types of Arduino. So first we have the LilyPad Arduino. This is basically round in shape and it has LEDs all over it. So these LilyPad Arduinos are used in e-textiles and wearable projects. So it can be sewn in the form of a fabric and mounted like over several power supplies, and they have sensors and actuators which are very conductive. So it has its own family of input, output, power and sensor boards. And next we have the red board. The red board is something, it's a very compatible device. It helps us in quick and easy project prototyping. That is, it can interact with the real world sensors quickly and gives us instantaneous values. So next we have the Arduino Mega. It is basically known as Arduino Uno's big brother. So it has 54 I/O pins, and out of which 14 are pulse width modulation pins, 16 analog pins, a USB connection, and a power jack, and a reset button. So it contains everything needed to support the microcontroller. That is the USB cable connected to the computer, and AC to DC, that is analog to digital adapter. So it is nothing different, no different from Arduino Uno. Like it won't be any faster. It's just that it has extra instructions and it can access to the extra flash memory. And then we have Arduino Leonardo. So this basically is generally used in health and security systems and also used in creating wireless keyboards. So this was the first board used in microcontroller with built-in USB. So this means that it is cheaper and simpler. So as it has a built-in USB, it can handle the USB directly and has code libraries which are available with the board, and so hence you can directly use it. In this course we'll be generally using the Arduino Uno R3, and this is the architecture of Arduino. So here we have the inner components which are present as a single chip, and this we have the microcontroller. In this case the microcontroller is generally Atmega 328, and then this we have the whole board. So first of all we have a microprocessor, that's basically a CPU. So this CPU is going to do some processing. So but for processing, uh, like a CPU is not enough alone, so it needs to have some memory. So here we generally have a S memory, which is static random access memory. So this memory is volatile and the data is generally lost when the power is removed. So if we consider here we have the memory here. So when we connect our USB cable here, that time this works because we're feeding in some input into this Arduino board. And when we remove it, there is no power supplied to this Arduino. So therefore, all the memory present in the SRAM is lost. And generally, the RAM would be of just 1 kilobyte or 2 kilobyte, unlike our mobile phones, which generally has like a RAM in gigabytes. So, but kilobytes are enough to run the C code. And then we have flash memory to store all our programs. So flash memory is generally of like 32 KB, and that's enough, like that's the maximum limit. So this is the basic structure. We have a microprocessor, we have flash memory, and we have a SRAM. And then it has minor peripheral stuff, but these are the three major components. So these three major components constitute the microcontroller. And now the microcontroller is a part of the Arduino Uno. It can also be called as a heart and or the brain of the Arduino Uno, but it's called like mostly the heart of the Arduino Uno, like related to a human body. Like a person could be brain dead, but his heart would still work. So, but if his heart stopped beating, then the person isn't alive anymore. So we could call this microcontroller the heart of the Arduino. In case like this doesn't work, then the board, like the whole board doesn't work as it stops taking input values. This is the microcontroller thing. It has 16 pins. So it doesn't like this things is generally of this microcontroller, you generally get it in many different sizes, but this is like the most common one. So this one has like a CPU, the timer, flash memory, SRAM, etc. So the main controller here is something, this is the main controller, but this one has another microcontroller known as Atmega 168. So this is generally used for communicating. So idea of using this interface like as a new interface, the USB interface will be able to communicate directly with this. So here generally we can use the C type cable, and we can connect B type cable, and we can connect it to the computer. So when you have program, when you have to program the Arduino, you have to program the data, and from the data from any other host, or for example like mobile phone, you can program the Arduino. So now you, with the USB communication, it receives the communication into here, and then it moves into all over this place. Now I know that was a lot to take in. Now I'll move in to the basics and of how all this works. So now we have digital pins, which are digital is something which takes in very certain values at a certain time. So now here these are said to be the digital pins. Here you can see digital pins, and the ones with the complement are known as a pulse with modulation pins, which I'll be explaining soon. So the digital input output pins are like from 0 to 13, that is we have 14 pins. So these pins will be helping you to communicate with the outside world from using some basic components. So these basic components can be like sensors and actuators. So for example, I have like 13 pins here, and these pins, I can take any one of them as my output. Suppose I take the seventh pin to be my, I wanted the seventh pin to be to from where I could get my output. So now I can take anything. Suppose I'll take a basic LED. So now when so I have already set my seventh pin to be my output. That's basically I made the configuration. So now after configuring my pin to be my output, I'm going to connect a uh, LED here. So LED, I can connect an LED, the anode I can connect it to the 7, and then the cathode I can connect my cathode to the ground. So with this, and then we could write a C code, which I will be explaining in the next session, we'll be teaching you. So you can write your C programming code and make 7 to be your output. Now, how do you make your 7 to be your output? So these are digital pins. So they take two values, either high or low. When the value is high, your LED glows, and when the value is low, your LED will not glow. So now I need to make my value at this point to be high so that my LED will blink. So because when I put it to low, that means the LED, it means 0, so it does not work. So now when I put this, I can write a code in which I can put my LED to be high. So if I put the LED to be high, then the pin will be in higher state. So this can help me blink my LED. So now coming to this symbol pulse width modulation. These are nothing but they're used to generate digital signals and over a user defined period, that is only when the duty cycle is on. So with this it can control the amount of power supplied to the electrical device and also encode a certain message. So this type of signal is also generally used in LED lightings. So depending on which pulse width modulation signal is active, like which is high during the, there are again various types. Now analog input pins. So now these are the analog input pins where we get some these. We have 6 pins here. So these are the signals where we get some real world signal values. Like some, suppose a sensor could be attached here. For example, a temperature sensor, and this could take in information with the world around you and provide it to the Arduino Uno. So it is that the act then the analog input this signal inputs convert the thing into a digital value. There's basically a analog to digital converter inside the Arduino board. So this converts the digital signal, an analog signal, into a digital signal, and it will send it to a microprocessor. So it this digital signal can only so this one can only process digital signals. So then it sends the digital signal to the CPU, and after that this process or signal was will be based on that certain code we wrote. So that is how it is used to convert the signal. So now the thing which converts the signal is an analog to digital converter. So now this is the an analog signal and this is the digital signal. And this is also said to be the, I have mentioned that the pulse width modulation works only when the duty mode is high. So this analog signal is generally, it takes, suppose we can consider this to be various values. So suppose if I consider this to be 1 and this to be 2 on a graph, we can't really specify like 1.1, 1.2, 1.3. So here at every value it takes uh, values from the outside world. But when you take it to a digital signal, it takes only two discrete, we can tell, say it as a boolean type. It takes only two values. So this is like 1, this represents the 1, and this represents the 0, 1, 0. So these pulse width modulation pins work only when the duty cycle is in on time. So here I said the value is 1. Also this could be said as, this can be set as duty cycle on, or with the value of 1, duty cycle off with the value of 0. So now now I'll tell you why there is a need to convert these analog signals into digital signals for the Arduino Uno to take in. So basically these analog signals are real world signals. That's like, suppose the audio signal. The audio signal I am talking is a analog signal, and you can expect there's a lot of discontinuous in this. So now the processing into a digital signal is very cheap. So like processing the analog signal into a digital signal is much cheaper. And another sharp difference is that in analog the noise gets amplified. That amplified means it gets changed like as you increase the number of stages, while in digital signal it gets reduced. Like here when a voice is amplified, here the number of stages increase, that is we have a very large number of uh, values coming in very low number of time. So but when we use a digital signal, it reduces all that. So since this processing is much easier and cheaper in digital, it all makes like sense to convert all these analog values to into digital values. so and process it in the digital domain. And generally we, for the Arduino to use it, we generally keep it back, let it stay in the digital domain. So now I like take the example of you listening to my voice. My voice is reaching you, like that is because my voice is being taken as an input, converted into a digital signal, then processed in the digital domain, and the number of stages are reduced. And then we have another converted called digital to analog converter, and which converts it back into an other into an analog voice again and sends it out to you. This is because the outputs should be in continuous domain and you can hear it continuously. But it is not the same in case of Arduino because it takes discrete values. Now, yeah, so the audio signal is basically a pressure varying wave. That is now when if I talk softly, now the pressure would be lower, and if I like shout, the pressure would be higher. So that's like a real world wave that is continuous. So if you convert it into electrical voltage waveform, it's generally done using a transducer. This waveform becomes amplified. So now amplifying the continuous waveform and then reconverting it into an audio would send it out to you. Now, this was the one I was talking about. So it takes an analog values. It has an analog to digital converter which converts the values. It modulates all the signals, and then it sends to the microprocessor. This microprocessor stores it in the flash memory. It stores the program in the flash memory and all its values in the SRAM, and then it gives a digital output. I will be showing you how to do it. Now, components of a Arduino. So we have 14 digital input and output pins, and these are generally written using a few functions in the Arduino programming. So, like example, digital read and pin mode and digital write. So, basically, in this, we represent these digital input and output pins. So, we these pins operate at a power operate at a power of 5 volt, and they can receive maximum of only 40 milliampere of current. So in the internal structure of the Arduino, they have resistors. So these resistors help them in all this, eliminating the extra current. So these value of these resistors is generally like 20 to 50 ohms, and they are also like they're connected by default. So now out of these 14 pins, we have some pins known as serial pins, which is 0 and represented by Rx, and 1 which is represented by Tx. So now these Rx and Tx pins are used to receive and transmit serial data. Now they are connected to the corresponding Atmega this thing, like internally, and to a serial chip. Now this external input pins 2 and 3. These are known to be for the configuration. That is, they interrupt a low value or the rise and falling edge. The rise and falling edge is this one. This is the falling edge, and this is said to be the falling edge. So these two pins 2 and 3 are said to be configured when there is a change in the value of the cycle. Now pins 3, 5, 6, 9 and 11. These are the pins. They're basically 8-bit pins, and these are the pins where we get an pulse width modulation output. So from these pins we can get an output from them, and they're usually written using the function analog rate. Now considering this, now taking this as 10 and 11 pins, 10, 11, 12 and 13 pins, these are pins are used for communication, and usually the pin number 13, this has a built-in LED connected to it. So we'll generally be using pin number 13 to show like basic structure of built-in LED. So when the pin 13 is high, we get the LED as on, and when the pin 13 is low, we get the LED as off. So along with these digital pins, we have six analog input pins, and each of them provide like 10 bits of resolution. So with 10 bits of resolution and six input pins, we have 1024 different values. So they measure a value of 0 to 5, but this limit they can be increased. So then we have the power USB or a barrel jack. So like yeah, it's known as power USB or barrel jack. So like every Arduino board need a way to be connected to the power source. So the Arduino, can be powered from a USB cable. So we have like a B type USB cable connected from the laptop or CPU to this, and this will act as a wall power supply, and this power is terminated into the barrel jack, this one. So the USB connection is also how you will load code into your Arduino board. So then I'll be showing you how you can install that later. So now I have explained you ground. So this is the ground pins where you can ground for the extra power to go off, and we have the 5 volt and the 3.3 volt, and these are base 5 volt pin gives the 5 volts of power supply, and 3.3 volt gives 3.3 volts of power supply, but we generally use 5 volts of power supply. So yeah, reset indicator. So this reset indicator is like consider a Nintendo. The Arduino has a reset button here. So pushing it temporarily will connect the reset pin to the ground and restart any code that is loaded into the Arduino. So this can be very useful, like in case you don't want your code to repeat. But if you want to test it multiple times, you can press the reset switch. Then we have the main IC, which I introduce you to all, and then we have the voltage. Okay, so I'll sum up once again what I've done. I have the reset button basically to reset the controller, the TX, and this, yeah. So these when it's given as input, so these two LEDs will blink. So these basically indicate the communication between your Arduino and your computer. So they flicker rapidly during the code uploading. The USB port used for powering the Arduino Uno and uploading your code. This I told you is the power connector. This is how you power your Arduino, and it generally accepts voltages between 7 to 12, and your Arduino board accepts a power output pin of 5 volt. And then these are the digital pins which I told you, which will be generally mentioned using the functions digital read, digital write, and analog write. And then we have the ground and 5V pins, which provide power and ground, which provide ground to your circuits. And we have pin 13 LED. So this is like a built-in LED, like you can also call it an actuator. Besides like being a handy target for your first blink sketch, this LED is also very useful for debugging. And we have this as the power indicator. That is a power LED. If basically indicates if your Arduino is receiving power, which and also useful for debugging. And these take the values using analog read, and this is the Atmega microcontroller, the heart of Arduino Uno. So I this is basically a sum up of everything I have covered. Your digital input and output pins. Plug in here is where your code goes in. Here you get an power here, and here it provides 5 volt battery, and always it's important to connect your circuit to the ground. And here are the analog pins when you generally use them to receive analog signal values. And you guys have any questions, you can ask. Also I could like For next session, we will have it on C programming and basics, and then we would have our session on MicroPython and Arduino basics. So you guys can go on and create a account on Tinkercad. I'll put the link in the chat box. Here you can see like this is the Arduino Uno. So this is basically the online simulator we'll be using for this session. So here is when you can write the code here, which is generally if this is basically the basic one, or we can actually write the normal code. So when I press start simulation, I'll have this inserted into this thing, and this will give me the basic values. So here it shows this on. So this basically tells that the Arduino is accepting values, and to here it shows that our Arduino is working. We haven't like given, now we can like connect an LED, and we can when we connect this we can like show this thing. So you guys have any questions, you can ask.
Excuse me, ma'am. I have a question.
Yeah, go ahead.
Uh, what kind of devices can we connect to digital pins, ma'am?
The digital pins are generally like you would connect it to a certain sensor, and from the sensor to the Arduino, you have something called jumper wires. So you would connect these jumper wires. Basically, you can connect your sensors. So you use these jumper wires to connect between your Arduino and sensors.
Okay, ma'am. Thank you.
Yeah, you're welcome. You guys have any more questions or anything? So I think we can end this session here. Thank you all for attending, and I think I hope it was of great use. Thank you.
Thank you.
Thank you.
Thank you.
Without you by my side, I can't survive.